In this video, we're going to go through the notes for section 8.3, which is data distributions. We're only going to do half of the examples in that section for this day. And so in this video, we will be able to find the measures of center and spread and compare data sets using statistical measures that are appropriate for the distribution of data. So in previous math classes, you've learned about the measures of center, like the mean, the median, and the mode. And then the only measure of spread you learned is the inner quartile range, which is the difference between quartile 1 and quartile 3. If you're looking at creating a box and whisker graph, which is what we'll be doing in the second example today. And so for the first example, we're looking at mean, which is a measure of center. It's the average of the data. So remember that to find the mean, we take the sum of all the values in the data set. So that is sigma x is the notation for that. And so sigma is this uppercase, it looks like an E almost, that always represents sum in math. And that's a Greek letter. So it's the sum of the values of the data set divided by the number of values in the data set, which we'll call n, for all of the statistical equations we use. And there's two ways that they note that symbol. So x bar, this is used for the sample mean. And mu, the Greek letter, is used for the population mean. For the purpose of standard deviation, that measures how much the values in the data set vary or deviate from the mean. So it means how far they spread out from the mean. And we always will use population standard deviation, which is denoted by lowercase Greek letter sigma. So again, the uppercase looks like an E almost, and then the lowercase looks like a cursive O with that little tail. Versus sample standard deviation has a little bit different of a formula, and that's denoted by a capital S. And so we're using population is why both of the values that we'll talk about are Greek letters to note them, so mu and lowercase sigma. So we're going to use a table to organize our work to calculate standard deviation. So again, standard deviation talks about how spread apart the values are from the mean. And so in this data set, we're given it as a stem and leaf plot. So remember that when I'm given a stem and leaf plot, they're giving me the values where ultimately these numbers are the tens place on the left side of the line, and then the ones place value is on the right side of the line. So when they're giving us these data values, they're telling us that the numbers are 9, 15, 18, 23, 23, and so on, just organizing it in a stem and leaf plot. The purpose of this, or the help of this, is it kind of gives us a shape. It shows us that there's a lot more values in the middle than there are on the outside, so that the numbers look like they're more centered around the middle of the numbers because of that 23s and 27s. So in order to find the standard deviation of a data set, what we have to do is list our X values, so our data set, in order. And it helps to do it in order just because of repeats and kind of checking our work. So the first X value is 0, 9, right? But I'm just gonna write number 9. So they tell us that our data set is 9, and then 15, 18, 23, 23, 27, 27, 32, 35, and 41. Okay, so they gave us those data values in a stem and leaf plot. Remember that n is the number of data values. And so if I look at these, there are 10 of those. So that means that for the purpose of this problem, n is going to be 10 because I was given 10 data points to use in this analysis. So what I'm going to do next is I'm going to find the sum of the data values so that I can then find the mean. So what this means is that I'm going to take and add these numbers together. So if I add up all of my X values, that's going to give me a sum of the data set. So remember that uppercase sigma of all the X values. is 250. I'm going to use that to find the mean. So mean is mu. Mu is the sum of all the data values, which we got is 250, divided by n, the number of data values, which we said was 10. So we're taking 250, dividing that by 10 in order to find the mean, which means that the mean of this data set is 25. Okay, so the mean of this data set is 25. We're going to use the mean in this column. So this is asking me to fill in everything with that value for the mean. So the mean is that mu, so I'm going to list 25 for all of those values. I'm going to list it for this first example, but we could just list it for the first one and know that we're writing the same number every time. Okay, so I'm filling in each of these with 25 because I want to do something with that next. So what we're working towards here is calculating the standard deviation. So the formula for standard deviation is this formula here. So this is what I do to calculate standard deviation. So this is telling me that I'm taking the square root of the sum, sigma means sum, of the difference between each data value and the mean, but that value squared. And then I'm going to divide that by n. Remember, since I'm talking about this data set, n is 10. And so using this formula for standard deviation, I have to figure out this value, which is what I'm doing here. So this whole table is going to give me the sum of the difference between each data point, the mean, squared, the sum of all of those. Okay, so I'm looking for that value so that I can plug it in here and calculate the actual standard deviation. So this table is organized in a particular way so that I can calculate that. When we take a quiz on this, this table would be given to you with the headers there so that you just have to know what each of them represent. So what mu is, that mu is the mean. So in the next column, I want to do x minus mu. So for each of these values, I'm taking it and subtracting. So 9 minus 25 is negative 16. 15 minus 25 is negative 10. 18 minus 25 is negative 7, and so on. So I'm going to fill in these values by subtracting those two numbers. In the first two columns. Then in the next set, what I have going on is that I have x minus mu, so these are my red numbers that I just found. They want us to do x minus mu squared. So that means that I'm taking these numbers and squaring them. So if they're negative, they're turning positive, and so all of the numbers here should be, because of this, all your numbers should be positive. So because you're squaring, second power always means something turns positive. So negative 16 squared is positive 256. Negative 10 squared is 100. Then we've got 49, 4, 4, 4, 4, 49, 100, and 256. So then that last value, so this value that I actually need to calculate my answer, is the sum of all of these numbers. So if I add all of this up and I find the sum, I get 826. So that means that the number that's going here when I calculate standard deviation is 826. So I took each of the data values, found the mean, subtracted each data value from the mean, squared that number, and then added those all up. And now I've plugged it into this formula for standard deviation. So this formula for standard deviation is the square root of the sum of all those last numbers that I got, divided by the number of data points, which was 10 again. And then I take the square root of that. So if I calculate this value, so that means that I'm going to take the square root of 826 divided by 10 is just 82.6. And so that means that sigma is about, if I take the square root of that, 9.09. So the standard deviation is about 9.09. The mean, which remember is mu, is 25. Okay, so that's finding standard deviation for a data set. Again, that's a long process, but that table will always be given to you on an assessment so that you just have to fill it in. The next thing that we're going to talk about should be a review. That's doing a box and whisker. So the 5-number summary are the values that are used to create a box and whisker plot. The values that we will use are the minimum, the first quartile, Q1, it's also called the lower quartile, the median, the upper quartile, which is the third quartile, because technically the median is the second quartile. We just don't name it Q2. And then the maximum value. So each quartile is the median of the lower and upper halves of the data. The range of the data set is the difference, so subtraction between the max and the min values. So I'm going to do, ultimately, that's really giving you a formula, right? So range is the max minus the min of the data set. And then the inner quartile range is the same thing, but it's the upper minus the lower quartile. So it's taking Q3 and subtracting Q1. So remember that when you're finding this stuff for a box and whisker, you have to make sure that your data is in order. And then you're finding the middle, and that's your median, and then the middle of a half, to get the upper and lower quartiles. So the first thing that we're going to do with our data is put it in order. And so because we were given actually the same data set that we just found the standard deviation for, it's already really given to us in order. We're just listing out the numbers again. So remember that this is telling us 9, 15, 18, 23, 23, 27, 27, 32, 35, and 41 are the data values. The easiest ones to find are the minimum because it's the smallest number. So our minimum is 9, and the maximum because it's the largest number. And so the maximum is 41. And so that tells us that we can find the range right away, right? So the range is 41 minus 9. And so that means that the range of this data set is 32. So there are 32 numbers between the minimum and the maximum value. Then what we want to do is we want to find the middle to find the median. So let me double check the median was green, right? And so that means that since I had 10 values, so if I'm looking for the middle, right, I'm ignoring the max and the min, and then I got the next two, and then the next two, and then the next two. And so what it looks like is that this is where the middle value is. And so when this happens, is that I have to find the average of the two numbers. Once I have two numbers in the middle, I'm finding their average to identify the actual median. So since it's between 23 and 27, I'm always going to have to add those two numbers and divide that by 2 to find the median. So if I have two numbers that are the middle of my data set, I'm finding the average of those two numbers, which in this case is 25. So you might even just be able to look at it, right, when it's a whole number like that, that it's 25 is perfectly in the middle of 23 and 27, and so that number is our median. So what happens here is that this allows us to now find the lower half and the upper half. And so when I'm finding the lower quartile, what I'm looking at is all the values except for the median. Since the median was not in my data set, I get to use the 23 and the 27 as like they're in each half, versus if the median was a number inside there, and we'll see that tomorrow, then I wouldn't ignore that value. So when I have it like this, where it cuts it in half like that, the middle of my data set now, I have these 5 numbers. This number is quartile 1. So that means that the lower quartile is 18. And if I do the same thing with the upper half, the number in the middle of that is the 32. So 32 is the 3rd quartile. And so when we're drawing a box and whisker graph, we have to create kind of a number line to use as a reference point of our graph. And so I want to draw a number line that will go from that will hold 9 to 41. And so a good number to go by is probably by 5, since my range is 32, right? I have 32 numbers that need to go across. So if I start with 5 and just go by 5s, that's going to make it easy to get to 41, to be able to plot 9 and 41. So if I use that as my number line, and then I have to use these points to graph my box and whisker. So I'm going to use a point for the minimum, quartile 1, median, quartile 3, and maximum. And I'm going to plot each of those as estimates, just as dots, to draw my box and whisker plot. So I've got 10 and then 18, sorry, 9 and then 18, and then 25, 32, and 41. And so I'm just putting points on that number line for that. Remember, the way that a box and whisker works is that the last 2 and the first 2 points are connected with a horizontal line, that's the whisker. And then the middle 3 points, I draw a box around them. And so remember that what happens is that this means that 25% of the data fits here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. So it's a way to kind of see how spread out sections of the data are. So what we can see from this, because the boxes are shorter than the whiskers, that means that the data is closer together in that section. The last thing that we needed to find was the inner quartile range. So the inner quartile range is, remember, Q3 minus Q1, which means that we have to subtract 32 minus 18. And so 32 minus 18 gives us an inner quartile range of 14. So there's 14 values in that middle 50% of the data. So what we're going to look at next is just organizing and being able to describe shapes of data. And so the shapes of distribution in general, we're going to talk about 2 main types. It's a skewed distribution and a symmetrical distribution. And so a skewed distribution has a shape that's stretched out either in the positive or negative direction. It's named after the tail of the graph, so like the short part, or that's also the location of the mean, so which side the mean is on. So in a skewed distribution, it's either going to be skewed left or skewed right. That's going to give us the a situation where the mean is either on the left, which means the mean is small, is less than the median, Or if I have a skewed right, the mean is on the right and the right side is larger numbers. So that means that the mean is greater than the median. Okay, so in skewed distributions, the mean and median are different numbers depending on where it's skewed. So if it's skewed on the left, that means the mean is smaller because smaller numbers are on the left. If it's skewed right, that means that the mean is larger because larger numbers are on the right. When we're using a skewed distribution, the median and the IQR are the best ways to describe the center of the data and the spread of the data. Okay, so median and IQR are the best way to describe skewed distributions. The alternative is a symmetrical distribution. So if I have a symmetric distribution, the mean, the median, and the mode are actually about the same value. In a true symmetric distribution, they are exactly the same value. And so notice that the graph looks the same on both sides. It's like that where the mean, median, and the mode are, it cuts that graph right in half. It's that line of reflection. And so symmetrical has a shape that when reflected across the mean, the display is roughly the same. In this situation, we'll use mean and standard deviation to describe the center. The mean, median, and the mode are all the same in a symmetric distribution. So in the last example for today, we're going to look at some data sets as numbers and then as visual representations to describe what measures of center and spread we would use to describe the data. So when I have a large number set like this, it's good to draw a histogram of some sort. So this histogram down here goes by ones because the numbers are close together, right? I have like 7 5s in this data set. This data set's a little bit more spread out. So when I draw a histogram, I'll probably go by 5s to kind of look at that. And so I'm just going to kind of do this a little bit less nice than what they did. I'm going to kind of do a mix of a dot plot and a histogram. So I know my smallest number is 10, and I have to go to 37, so about 40. So I'm going to go by 5. So if I do 10 up till 15, and then 15 to 20, 25, 30, 35, 40. So what I'm going to do is make a dot plot so that I can identify how many data values are in each of these bins. So I'm thinking about this as I want to draw a histogram, but I need to determine how tall I need this to be really, so how many numbers I need to go up. And so what I'm going to do is just organize my data that way. So if I think about between 10 and 15, I only have 2 numbers that fit in there, right? I have 10 and 13. So I'm going to use an X just to represent, or a dot just to represent each of them so that I know how high I need to make that part of the histogram. So then between 15 and 20, so that means I'm doing from 15, 16 to 19, right? So it starts with this number and it ends with a number right before there. So there's only one number in that section. And then 20 to 25, so 20 through 24 are going to go in here. I only have 2 numbers. And then from 25 to 29, I've got 3 numbers. 30 to 34, this is my big one, 1, 2, 3, 4, 5 numbers. And then 35 to 37 has 2 numbers. So if I draw this out, I need to go to 5. So my first bar is going to be too tall, then 1, then 2, then 3, and then 5, and then 2. So if I were to have to describe this data set as a one distribution, I would say that this data set is probably skewed left, because that shape would kind of be the best shape to represent it. And so if it's skew left, the best measure of center is median, and the best measure of spread is IQR. So to answer the question, my answer is median and inner quartile range for example 2A. The next set is easier because I'm just given the visual. So again, I'm looking at what would I best describe this data, and this one is more symmetric. It's not perfect, but it's closely symmetric. And when it's symmetric, it's mean and standard deviation. So the answer for this one is mean and standard deviation. And finally, for the last one, if we look at the data set, it looks like it's the opposite skew of the first one. So it looks like it's skew right. But remember that the direction of the skew does not change the answer for this question. So that's still the median and the inner quartile range. That will be the best representation of center and spread for any skewed data set. So all those examples will help you with the assignment for day 1 of this section. The next video will get you through the assignment for day 2.